Hello everyone, welcome back, and today we are going to learn about flight, the lift, how a flight takes lift, how the lift is generated. एक एरोप्लेन लिफ्ट कैसे जनरेट करता है, हवा में उड़ता कैसे, उसके लिए आपको दो तीन चीजें बताना बहुत जरूरी है। जैसे कल हमारी डिस्कशन हुई थी अबाउट प्रेशर, प्रेशर क्या है मैंने थोड़ा सा आपको बताया था, बट टुडे आई विल ब्रश अप अगेन लिटिल just to again get you in the mood. So I'll tell you something about pressure. And before I start anything, there are a couple of things which I want to show you. First, we will look at this image here. Let me share it. Can you see this image? Everybody?
Yes, sir.
Okay. Now, first I want to show you this particular shape of the wing. I'll change the color and I'll draw a wing. Can you see this wing, how it is shaped here, where I'm drawing? This shape of the wing. Sorry, it has gone a little bad, but I'll draw it again for you. This, can you see? Now I'll draw it in a big way. So the wing is shaped like this at the tip. This is the tip of the wing. Okay. So if there is a full-fledged aircraft and you are looking at, this is the nose, these are the wings, these two are the wings. So they have planted the aircraft like this. So you're looking at the tip of the wing. So the tip of the wing has a shape like this. I can also draw a shape like this, which is the other side. So whenever I draw this shape, you should know that this is a wing. Fair enough?
Yes. Okay.
Okay. So now I'll go back to the menu. Now, second thing which I wanted to show you or brush up was about pressure. So here I want to tell you that pressure is of two kinds, static and kinetic. And the total pressure which comes after adding kinetic and static remains constant. It remains constant means that if one grows, the other will have to fall. This number will not change. So for example, हम मान लेते हैं कि total pressure है 10, static pressure मान लो है 2, तो kinetic pressure कितना होना चाहिए? गायत्री, can you unmute yourself and tell?
8.
8, exactly. So because this had fallen down, so this has to rise to give the total answer as 10. This will remain constant. Now, if this is constant and one pressure is 5, kinetic is 5. So Rohan, can you tell me what should be the static pressure? Can you hear me, Rohan? Maybe he cannot hear me. Akshay, can you explain?
Yes, it will be 5.
It will be 5. Exactly.
Total pressure has to be same. So if one increases, the other one will have to go down.
Very nice. So we have understood this phenomena that total pressure remains constant. So one has to rise, one has to fall. This is a very simple definition about pressure, which we have understood. Now, how it will be used for the purpose of lift, that I will just discuss with you in a minute. In the meanwhile, I will show you there was a person called Bernoulli. Bernoulli. He did an experiment which was very, very useful for us, for especially the aviation industry. Okay. Now, what he said was he introduced something like this. This is a pipe. It's hollow. You can see my eye through it. Maybe you can. Yeah. So this is hollow and it's a pipe. तो बर्नौलीज ने, जैसे हमारे नेता कहते हैं कि यहाँ से आलू डालूंगा यहाँ से सोना निकलेगा, ऐसा कुछ नहीं बोला उसने. उसने बोला यहाँ से मैं पानी डालूंगा तो यहाँ से भी पानी निकलेगा, यहाँ से मैं हवा डालूंगा तो यहाँ से भी हवा निकलेगी. बट उसने एक पाइप में चेंज कर दिया. दिस इज व्हाट ही डिड. ही पुट अ बेंड इन द पाइप. इसको यहाँ से बेंड कर दिया बीच में से. तो यहाँ पाइप मोटी है, यहाँ पाइप मोटी है, बीच में से बेंड हो गई है. एंड नाउ आई वांट टू आस्क यू कि जब हम लॉन में पानी दे रहे होते हैं, पाइप हाथ में होती है, सो व्हेन वी प्रेस द पाइप, इसका जो लास्ट का एज होता है उसको प्रेस करते हैं तो पानी एकदम शूट कर जाता है. इट गोज वेरी फार. हैज एनीबडी
Yes.
seen it?
Yes.
Yeah. Okay.
Yes.
Yeah. So what is happening is actually it is gaining kinetic energy. उस पे प्रेशर बढ़ गया है इस पॉइंट पे, तो वो काइनेटिक एनर्जी में कन्वर्ट हो गया. स्टैटिक इज कन्वर्टिंग इनटू काइनेटिक. सो देयर विल बी ड्रॉप इन द स्टैटिक एंड इंक्रीज इन द काइनेटिक. सो here I will explain this Bernoulli's theorem. So this is what Bernoulli did. He made a pipe like this and put a bend in between like this. Okay, like that. अब इस जगह से water is flowing and coming out like this. Okay, to give you a better picture, I will share this picture with you. Can you all see? Now, this is again Bernoulli's pipe, you can say. It's a tube and air is flowing from one end to the other. The direction of the flow is this. So, he said if there are 10 molecules here, okay? I'll just use a better pen. He said there are 10 molecules of air or whatever you're using. How many are there? 10. So here also when this particular segment of water or air that reaches the center part, which is the bent part, again the molecules will remain same, 10. And at the end, again, there will be 10. So, what it basically means is that the mass will remain constant. The amount of molecules in that water, in that segment of water, will remain constant. They will remain same. There will be 10 molecules entering, 10 will be in the center, 10 will reach out. So they all will flow together. So if mass has to remain constant and they have to flow, what will have to happen? Like we discussed, if this is the pipe and I'm watering the plants and I press the edge of the pipe, the water will go fast. So it means when this part of the pipe is pressed, the velocity at this place should be, Rohan?
Higher. It will be higher.
Yeah. Velocity will be high because it is pressed. Okay. This part of the pipe here, we call this cross-sectional area. So we'll denote it by A, letter A. So this is also cross-sectional area. So Akshay, which one is bigger? This one or that one?
Left side one is bigger.
This one is bigger. Okay. So we'll put an arrow which denotes big. And here we'll put an arrow which denotes small. Okay. So when the cross-sectional area is small, velocity is high. When the cross-sectional area is big, velocity should be less.
Yes.
Okay, we've understood this much. Now we will talk about pressure. Please remember, always in aviation, when we talk about pressure, we are automatically talking about static pressure. We are not bothered about kinetic pressure unless specified with what will happen to kinetic pressure. Answer, otherwise just assume that they are talking about static pressure. So previously discussed that if a place is bigger, this area is big, a lot of water is entering in, right? It has got a lot of space. So velocity is low. Velocity is low means static will be, static pressure should be
High.
Low.
high.
High.
Exactly. Correct. Very correct. Because if the velocity is there, then kinetic energy is associated with it. If velocity is more,
Kinetic.
then kinetic pressure should be more, not static.
Okay.
So here velocity is less, so kinetic pressure is less, so static pressure should rise.
Right.
So static pressure is high.
Right.
And then we are left with temperature, which I will discuss with you in a second. But here static pressure, what will happen to it? Velocity is high, so static pressure should be low because
Low.
kinetic pressure is high
Is
because
it
of velocity.
increasing?
So the other has to fall. Now temperature, what happens is, you must have noticed, if say there is a cube of ice, okay, and in this cube of ice the molecules are very tightly packed. The water molecules are very tightly packed, all of these. But if there is water lying somewhere, if this ice melts, then the molecules will be loosely packed. So when the molecules are tightly packed, it means the thing has to be cold. And if the molecules are loosely packed, it means it has to be relatively hotter.
Warm.
Relatively hot, relatively to the cube, ice cube. So it means when the molecules are tightly packed, the thing has to be cold. Here, the area is less and 10 molecules are here. Here, area is big, but 10 molecules are also here. So which one is tightly packed here? This is point A, this is point B. So at which point molecules are tightly packed?
B.
I can't hear you. Anybody can answer?
B, sir.
B.
B. So at B, molecules are tightly packed. So this is supposed to be cold. Temperature is less. Whereas in
Okay.
this case, molecules have a lot of space to move around. So this will be hotter relatively. So temperature is high. For DGCA, you have to keep these two equations in mind. Questions will come if cross-sectional area is low, is less. What will happen to pressure? What will happen to temperature? What will happen to velocity? So these two, you should have these two things in your mind all the time. And it's fairly easy the way I've explained it to you, why the pressure is going to be low, why the temperature is low, why the velocity is high. You can yourself, if you forget, sometimes maybe you forget, then you just picturize a tube which is bent. Now you will understand if the cross-sectional area is low, is less, then kinetic energy will be more, kinetic pressure will be more. If kinetic pressure is more, then static pressure has to be low. So you can obviously make out. And if the area is small and molecules are there, a lot of molecules, they are closely packed, then it has to be low temperature. Temperature has to be low. And because the area is less, so how I hold a pipe in my lawn to give water, when I press the edge, it shoots, the water shoots. So it means velocity increases, so velocity is up. So we can very easily get to the conclusions of these two. Now, how they are important for generating the lift, we are coming to that. So listen to this carefully. Now I'll show you another picture of, again, a venturi. Venturi, this is a Bernoulli's kind of, where Bernoulli had proved this theorem. Okay, Bernoulli said that whenever the water or anything is passing through air or water or anything is passing through this place, so this pipe, and the pipe is bent from in between. When the pipe is bent, it's called a venturi. So whenever this is happening, the molecules entering will be remaining the same as molecule which are in the middle and molecule exiting. So mass is constant. That's what he actually came up with. And because of this mass constant, he came up with, if the cross-sectional area is low, then the pressure, static pressure, will be, can somebody give me answer?
Low.
Low, correct. Temperature will be low, velocity will be high, right? Now going back to the previous picture, one more thing which I wanted to tell you, which actually DGCA people quite commonly ask this question. You see the distance between these two lines, the distance between these two lines and the distance over here. Which one is bigger? This is point A, this is point B. So distance between the lines at point A is much bigger than the distance at point B. Yeah?
Yes.
So that shows that when the lines are converging, they are coming close together. When the lines are converging, velocity increases. And when the lines are diverging, they are going away from each other, the velocity is decreasing.
Decreasing.
Yeah.
Okay.
So in DGCA, they will ask you this question. The converging lines means velocity increasing. Diverging lines means velocity decreasing. So keep this in mind, very, very important. Okay. Now we will put all of this Bernoulli's theorem into our practice of lift, understanding how to generate lift. I'll go back to my diagram, which I had made earlier, this one. So I will, this is a venturi, if I delete everything here and the line which was here, I bend it backwards and make it like this, right? And I delete this. Does it look like the wingtip which I did show you in the very beginning? जो starting में मैंने wingtip दिखाया था design, उसकी तरह design है ना इसका, like this.
Side of the wing, sir.
Yeah, the side of
Side
the
of the wing.
of the wing. Yes, it has got the same design. Okay, that is why I showed you the wingtip in the very beginning. Now what happens around the wing? This is the wing. This is normal airflow. Okay, ambient air. This place in between is called boundary layer. So in this place, the boundary layer, this place between this line above and the wing, this behaves like a venturi. Can you see it has become a venturi? Air is coming like this and it will pass like this. Air will come like this, it will pass like this. Okay. So here the lines, you can see the distance between two lines is reducing. It's converging basically. Lines here at
Converging.
cross section, they are converging.
Converging.
Okay. So when the lines are converging, velocity goes up.
Up. Increased.
And here the lines are diverging. So velocity goes down. This cross sectional area is bigger than this one. This is B. This is A. So A's cross sectional area is big. So what will happen to pressure? Static pressure is more.
Static pressure
Temperature
increase.
is more. But
More.
in this case, at this place, velocity is high. Because this is a small area, temperature will be less. Pressure
Less.
less. And
Less.
area is low.
Area. Less.
So here we have understood that the pressure is low. And this is the basic knowledge how the aircraft takes a lift. Before I conclude, we are very near to solving this equation. I just would like to put your heads to this point also. This is a mountain. This is a ball here. This ball will go down. Okay? It is natural for the ball to go down. It is at a height. It is natural for the ball to go down. A ball cannot go up the hill. It can come down the hill. So it is but natural that things go from high to low. Anything which is at a height or anything which is a high thing, the things at high places will tend to go towards low. Okay? Understood the fact? Now we will draw the wingtip again. We concluded here the pressure is low. Pressure was low here. Yeah. Now, if you see the bottom of the wing, here the air is coming. This is a venturi. Air is coming and flowing straight. There is no diversion, conversion, nothing. This area, this area, this area is all the same. So here, what things are going to be? Same as this. Cross-sectional area is big. Pressure, static pressure is more. Temperature is more. Velocity is less. Same case here is big. Pressure is more. Temperature is more. Velocity is less. So here we have come up that at the bottom of the wing, pressure is more. Okay, understood? So we will delete all the rubbish and high pressure. Now, because of the high pressure at the bottom of the wing, it will try to go up. It will try to go towards low. The high pressure will try to go towards low and balance the pressure. When there is high pressure under the wing and low pressure above the wing, the high pressure tends to go up and balance the low pressure above the wing. So high pressure under the wing will try to push because it's trying to go up, high to low, things to go. So higher pressure at the bottom will try to go to the lower pressure at the upper edge of the wing, and it will push the wing up. That's how the lift is generated. This is the basic explanation for how lift is generated. Have you understood, everybody?
Yes.
Yes, sir.
Any questions?
Not.
No questions.
No questions.
All right then. If there are no questions, then I'm sure everybody has understood this pretty well, and we'll continue the class after a short break. Okay. All right then.
Okay.
Okay, sir.
10 minutes break. See you, everybody.